Hey everybody, it's Tyler here at the Texas Cup, checking out Team 11155, Clash of Coders, coming in from San Antonio. And we're going to be looking at this pretty awesome robot here, talking about intake, but even more than that, it's going to be their automated shooting. And it's a little bit special, so I can't wait to get a little bit more into that and what's going to happen. And today here, by the way, I'm here with Wesley and Leo, and we're going to be checking out what makes this robot so awesome, all here on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now.
So Wesley, we're going to start out on this robot here, talking about the intake on the front here. So talk to me a little about what went into it, some of the iterations you had, and we'll kind of work into the hopper as well.
So we started off trying to figure out how we were going to be able to get the rings up. We first wanted a intake that was going to take them relatively lower, so that we didn't have as many iterations of this of these rollers.
Sure.
But we found that with the hopper, with our design for the hopper, we had to have taken up a lot. So we had to create this arch thing on the side for the ring transportation. Another important part of our intake is specifically the this front part right here. This blocks out multiple rings from coming in at the same time. As you can see right there, it only allows one ring to enter, so you don't have any stacked rings inside this compartment.
Can we see, let's actually put that up and actually see the rings come in that way. I'd be very curious to see how that works.
Okay.
So can we stack them right? So stack those last two and let's see what happens. So there you go, just like you described, right? So we saw them start to go in the hopper. Talk to me a little about the hopper mechanism and how that works as well.
So after they go into the hopper, we have our, we hold the rings here in sort of a magazine type compartment storage system. And from here, we use one of our speed servos on the on this side to quickly fire them into our shooter mechanism. This obviously all this allows us to use the gravity so that each one loads into the next one. So there's no time wasted between firing shots by just manually pushing the ring into the shooter.
Well, that's a great segue to go into Leo to speak about the shooter. And Leo, something I'm very interested in hearing is that you guys have a very low shooter, right?
Yeah.
But you have that automated shooting as well, so I'm interested in hearing about that. And then also the decision process of doing a low shooter, because it can be blocked that way potentially, right? So talk to me a little bit more about some of the strategy and concept behind that.
So actually we had the shooter is low, but one of the nice things is we're actually shooting from the back of the robot.
Yes.
So it actually gains quite a bit of height before the start.
Sure.
And so when the ring comes out, it's actually coming out about 12 inches above the ground. So you still need a full height 18-inch robot to properly block that. And if we move even slightly back, we can avoid that. And we also have an angled shooter. So this shooter shoots out at about 17 degrees to the right.
Sure.
Which means that even if there's a robot lined up in front of us, we'll actually shoot around them to the right. And also, typically we're on the opposite side of the field because of our auto aim. So even if the robot blocks us in front, they'll actually have to be offset almost 45 degrees off to the side because we're shooting all the way across the field. So that's a nice thing there.
So a lot of calculations to do if they want to play defense, that's what you're saying. I got you, all right.
And then the other nice thing is, so standard two-motor shooter, we also have underneath the robot, I'll go ahead and, here Wesley, if you want to lift that up. Underneath the robot, we have this steel flywheel in here. It's 4 inches in diameter, and that's our inertia wheel. It weighs about 3/4 of a pound. And so when we're fully spun up, we can shoot out all three rings in, our max is 0.7 seconds for all three rings. So we index pretty fast, and it's extremely consistent because for us, although for most teams they're shooting on the line and a little bit of inconsistency between rings is fine, whenever we're shooting we can shoot almost from the back corner tile on the opposite side of the field. When you're shooting from that far away, even a minor inconsistency in the speed that ring's coming out is going to result in you hitting that mid goal and missing wildly.
How long does it take to get up to speed? Like you said, 0.7 to shoot
1
out.
second.
Does that include? Okay,
1 second from 0 to the highest speed that we shoot at.
That makes sense. Tell me more about this auto aim. How you came up with it, and then more importantly, like how you truly implemented it on your robot.
Yeah, sure. So from the beginning, we decided that aiming manually will almost always be slower than having the robot aim for itself. And so we just wanted to make it shoot automatically. And our initial thought was just to use a camera, but we found that the camera loop time, since it maxes out at 30 FPS, is pretty slow to run a PID control off of, and so you have to remove the robot pretty slowly and it gets kind of sluggish. And at that point, manual aiming is faster. So we implemented odometry in as well. And that allows us for two things. First of all, we can, whenever we spin up our shooter, because we don't have it running the whole match, whenever we spin that up, it actually aims the robot using odometry.
Okay, yeah.
But the issue with the odometry is it'll drift over time,
Yeah,
and
right.
especially with heading. Heading will drift a lot over a match.
Sure.
And so after we aim with odometry, we'll double check with our camera. If the camera determines that the ring's going to go in anyways, it calculates distance. So we have several equations on our robot, one of them being calculating distance using the camera. And so if using that distance, we'll calculate that distance, work out the speed we need to spin this flywheel out. Since we are a fixed angle shooter, we'll spin up this flywheel at the right speed and fire those rings in. And if it's off, and we know that our odometry is off, we'll make a corrective measure using the camera. So we'll convert the error into degrees, rotate the robot using odometry again so that we can have that faster PID control.
So you still manually shoot it though, right? So it will auto aim, but then you have to still press something in order to shoot.
Well, you
them
press
out.
the button to aim it, and as soon as it's aimed, it just fires 3 rings.
Oh, okay, very
So
interesting.
you just hold down the trigger, and while you're holding down that right trigger,
It does all that
it
in one
aims
process.
and then just shoots. If you let go of it at any time, it'll cancel it on the spot. So you can either fire off one ring and then stop it if you're fast enough, but it's pretty fast at shooting those 3.
Yeah.
And so it'll aim, work out distance, and then it'll actually update the heading on the odometry. So
Makes
we
a lot of
remove
sense.
drift.
Yeah, that's really cool to hear. You're right. You kind of mentioned before that. Yeah, you really haven't seen one that incorporates both of those methods into that. So really cool with that. So 11155 once again, Clash of Coders coming here from San Antonio here at the Texas Cup. Good luck the rest of this competition.
Thank you.
And you never know if we see you guys in the future one as well. Wish you best of luck in that too. Thanks for taking the time.
Thank you so much.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.